Welcome Year 8s to this video. As you can see, in it we're going to be looking at solving algebraic equations. In other words, just solving equations. So this is a really good part of algebra. So far we've been looking at just substitution, where we replaced a pronumeral with a value. But now we're going to get to the really good stuff, and that's where we actually have an equation. We have something equal to something else. So we've got an equal sign in our mathematical sentence, and we're going to try and work out what the value of our unknown is. Now, in these examples, most of them, well, in fact, all of them, I think I use X. That's a really popular one that we use. But of course, you can use any letter to represent an unknown value. I've started off really basic here to remind you of what we did when you were in year 7. As you can see here, we've got an unknown number and we're adding 3, and the result is 5. Now, obviously, when you look at this, a lot of you will look at it and go straight away, yep, that is 2. And that's fine. When you've got this is called a one-step equation. When you've got one-step equations, if you can look at it and you can see what the answer is, then by all means, you are welcome to put what the answer is directly underneath. But what we're going to find in year 8 is it's not always possible to do that, because we're going to look at two-step equations. So when there's more than one operation, the only operation in this one was plus 3. We're going to have some with more than one step. And what we also might find is that sometimes our answer is a fraction. It's not a whole number. So sometimes it's not really obvious what the unknown number is. So that's where we're going to make sure we use the techniques that we started using last year in year 7. We're going to continue to practice that, and we're going to continue to make sure we show correct workings as well. So with this one, if I was to show how do I know that x is 2, what I can do is have a look at what this is telling me, which is x plus 3, and I have a look at that operation there. And then what I want to do is do the opposite operation to adding. And I want to do that to both sides of the equation. So at the moment, it's got add 3 to x. What I'm going to do is I'm going to undo that adding of 3, and I'm going to take that 3 away. Now, whatever you do to one side of an equation, you have to do that to the other side. Because if you don't, what you're doing is actually changing the equation. We never want to do that. When you are solving equations, by doing something to both sides, you're creating what we call an equivalent equation. So this here is equivalent. And I'll mention this again with some examples where we've got multiple steps. These are equivalent because x is equal to 2 in both of those sentences. It's really important that when we do choose to do an operation, that we do it to both sides and that we show that we've done it to both sides. So the reason that I subtracted 3, that was because I added 3, or 3 was being added to x. Now if I do that to both sides, you'll see now it says x plus 3 take away 3, and effectively that there, adding 3 and taking away 3, is cancelled out, because it's like me giving you $3 and then taking that $3 away. You're back where you started again. And so that means that our x is just on its own, so we call it isolated. And on this side, on the right-hand side, we've got 5 minus 3, which clearly is 2. So we wouldn't go through all of that detail with just a one-step equation, but I'm doing that now just to, I guess, lay some of the groundwork for what I'm going to do in some examples. So just a reminder, opposite operations is what we're going to be using. And you know these already, but just as a reminder, opposite of addition is subtraction, and then opposite of subtraction, addition. Opposite of multiplication is division, and vice versa. And so I'll be referring to these opposites, or also known as inverse operations. It's another word that we use for the same thing. I want to show you some examples now, and again, you can obviously pause the video at any point if you want to be able to have time to write these down. Or you can watch me do it and then you can pause and write it down afterwards. So here's an example where we may not immediately know the answer. We can see 3 times something is 25. Now the reason we may not immediately know the answer is you can see that I actually don't have a whole number that multiplies by 3 to give me 25. I know 3 eighths are 24, so that's not quite there. And so what we want to be able to do is work out how can we get a result here? How can we know what x is? I'm going to do what I did before. This means 3 times x. And the opposite of timesing by 3 is to divide by 3. And so since we don't use the division symbol in algebra, we use this symbol here like a fraction, what I'm going to do is divide both sides by 3. And as you can see, the reason I did that was because on this side, 3 divided by 3 is just 1. And so now I've got 1x on this side of the equation. Over here, I've got 25 over 3. Now that is actually a fraction that cannot be simplified. So I can leave it like that. That's my answer, 25 over 3. If I had something that could be simplified, say I had 27 over 3, then I could simplify that to 9, and I would simplify whenever I possibly can. So look for common factors on the top and on the bottom. Now 3 doesn't go into 25, so this one is finished. You can obviously change it to a mixed number if you want to. It's not always necessary unless you've been specifically asked to do that. So how many 3's go into 25? Well, it goes in 8 times. And then what's the remainder? Well, there's one remainder. And that remainder is divided by 3. So it's 8 1/3. Now, what I can do always, so whenever you are doing this, whenever you are solving, you can always check your result. And that's what I'm just going to do quickly now. This one's not as nice a one to check. But I was told that 3x had to equal 25. So what I'm saying is, if I look at my answer, 25 over 3, is 3 times 25 over 3 equal to 25? Well, yeah, it is. You can do it the long way by going 3 by 25 is 75, and 75 divided by 3 is 25. Or we can see here that we can cross cancel, leaving us with 25 equal to 25, obviously. Same number. So I recommend that you do always check your results, and we're checking by substituting. I'll try and remember to do that as we go. Here's another one over here. This is the one on the right-hand side. This is a 2-step equation. 2 lots of x take away 3 equals 17. The first thing I'm going to do is, if I was to read this sentence, 2 by x take away 3, I want to look at the last operation that's happened here. Because when I work backwards, I don't want to actually work with this 2 times x just yet. The reason I don't want to do that is that's what happened first in this sentence. It was first multiplied by 2 and then 3 was taken away. So if I'm working backwards, I have to work with this bit first and then I work with the 2. Sometimes that can be a little bit confusing, and I understand that, and that's something that we can talk about in class if you're still a bit unsure. So this is take away 3. I'm going to do the opposite of taking away 3. I'm going to add 3. On this side, that means this bit now is gone. Taking away 3, then adding 3 cancels out. 17 plus 3 is 20. And now in my new sentence, these two are equivalent. This one and this one are equivalent. It's equivalent because I did the same thing to both sides. Now what I want to do is I've got 2 times x equals 20. Remember, that's a times in there, invisible times. Now I'm going to divide both sides by 2. Like so. This cancels out. 2 divided by 2 is 1, leaving me with 1 lot of x. I don't have to write the 1. 20 divided by 2 is 10. Just as a checking process again, just change colours. 2 times x take away 3 has to equal 17. So 2 times 10, take away 3, has to equal 17. So we get 20 minus 3 equals 17. Yes, it does. Left-hand side equals the right-hand side. So that's my little check that I know this answer of 10 is correct. Now here's another one. Looks a little different this time. I've got 3 lots of x is being divided by 4, and that's equal to 12. So the last thing that happened on this side was the division by 4. So what I'm going to do is times both sides by 4. So it looks like this. If I write it out a bit more clearly, it's being times by 4. And on this side, well, 12 fours are 48, so I'll just put that in now. The reason that I did that, reason that dividing by 4, then timesing by 4 works, because that then it allows me to cancel these out, because 4 divided by 4 is 1. And now on this side, all I've got is 3x times 1, which is just 3x. So 3x is 48. Finally, 3 times x is what's happening here. I'm going to do the opposite of that. 3x divided by 3 equals 48 divided by 3. Again, why did I do that on that side? It's because it's the opposite of timesing by 3, and by doing the opposite, it's now cancelled out. All that's left now is doing 48 divided by 3. So if we're not sure about that one, well, we can do it, call it the slow way. 3 into 4 goes once with how many remainder? So 3 into 40, I should say. With how many remainder, and then we carry that across. 3 into 4, sorry, I was right the first time when I said 3 into 4. That was 1 remainder. It gives us 6 into 18, so that gives us 16. Made a bit of a mess of that explanation, I'm sorry. But basically what I was doing was that. Alternatively, I just look at the 48 and I go, well, 3 doesn't go into 40 perfectly, but it does go into 30 10 times. And then I'm left with 18, and I know that 3 goes into 18 6 times. Okay, this one over here, I've got a negative on the right-hand side. So I just wanted to show you that doesn't matter there's a negative there, because I can still do the same thing that I normally do. Just have to be careful when I'm adding or subtracting with negatives. So just like before, 2x, then take away 11. So I'm going to add that 11 on first. On this side, I'm left with 2x. And now I just have to make sure I consider the negative. I'm at -7 and I'm adding 11. So 7 units below 0. So 7 of those units in the 11, that's going to bring me up to 0. But then there's another 4 units that I need to go to the right-hand side. And so from here you can see, well, x has got to be 2 because 2 2s are 4. But if I was wanting to show how I got that, this is what I would do. X equals 4 on 2, which is 2. So there's, I guess, some basic ones to start off with. I do have a couple more examples to show you. I like this one here because sometimes when we see the terms are written the other way around, or not the other way around, but I guess here the 4x is being subtracted from 6. So it does look a little different to some of the other ones we did, that this x term is second, not first. So what do we do here? Well, we do exactly what we normally do. I recognise that this number is a positive 6. Now I'm just writing that there to show you why I do what I'm about to do. Since this is a positive 6 here, it's like saying adding 6. And so I'm going to take away that 6 to start off with. Now here, all that means is this 6 and this take away 6, that's the bit that's going to cancel out. Effectively, I'm going to do this. to the left-hand side of the equation. But I don't really want to just rub it out, so I'm going to bring it back. There it is. I've taken away 6 from both sides. That leaves me with just that negative 4x. Notice that negative there? It has to stay there, because that's part of the coefficient of this x term. It's negative 4, or taking away 4. And over here we need to do 22 take away 6. And that's going to give us 16. From here, we have negative 4 times x equals 16. So I'm going to divide both sides by this number here by negative 4. So that looks like this. Just like before, if I've got a common factor on the top and bottom, so common factor of negative 4, like so, that will simplify to 1, to positive 1, because a negative divided by a negative is a positive. And so you'll see that's why dividing by the negative 4 was essential. It left me with x on the left. Now all I have to do is 16 divided by negative 4. So 16 divided by 4 is 4, and this is a positive 16 divided by a negative number. So I have negative 4 as my answer. Now again, I think I forgot to do this with some of my other examples, but again, what you can do is you can simplify to check. So if I do, I've got no space. If I do just on the side here, 6 take 4 times negative 4, I have to get 22. So this is 6 take 4 times negative 4 is negative 16, equals positive 22. This is 6 taking away a negative. Taking away a negative is like adding that number. And 6 plus 16 is 22, so this works. My left-hand side is the same as my right-hand side. So again, I might have forgotten to do that with the previous example, but always try and check your answer. Okay, so the last example of this form looks like this. X divided by 5 plus 7 equals 22, or you might hear me say x on 5, because the x is on top. X on 5 plus 7 equals 22. Okay, first thing, not going to deal with that 5 over there yet because the 7 was added afterwards. Let's deal with that bit first. Let's take away that 7. That will leave me on the left-hand side with x over 5 equals 22 minus 7, which is 15. Okay, now what we have to do is I've got two sides of the equation. This side's being divided by 5. I want to now times both sides by 5. The reason I do that is I can then cross these out. 5 on 5 is 1. Left with x on that side, and now all I have to do is 5 times 15. So we can do 5 tens are 50, 5 fives are 25, 50 plus 25 is 75. Okay, I can check that now if I want. 75 divided by 5 plus 7. That's got to equal 22. 75 divided by 5, well, that's got to be 15. And 15 and 7 is 22. So checked it and it works. To finish off with, I just wanted to show you that we can solve problems that are in words. So here's one here. With problems that are in words, you have to first get them into an equation and then use that same process we've done before to solve them. We've got here a number is multiplied by 4. It says a number because we don't know what that is. We're going to assign that a letter, a pronumeral, and I'm going to use x. Now it says it's multiplied by 4. Now you want to go like this, I know, but we don't tend to write multiplication like that in algebra. So what we want to do instead is write it like this. It's multiplied by 4, which means 4x. And then 4 is added. So after that, 4 is added on. It says the result is negative 16. So the result of doing this, so what this is equal to, is negative 16. Now that we've got our words into a mathematical sentence, now we will solve. So just like before, take away 4, take away 4. On the left, we've got 4x. Negative 16, take away 4, so I'm going further negative. I'm going to the left of the number line. By 4 units takes me to negative 20. 4 times x, so 4x divided by 4 is negative 20 divided by 4. That cancels out, and I'm left with x equals 20 on 4 is 5, but a negative divided by a positive is a negative. So my solution is x equals negative 5. We can test that. 4 times negative 5 is negative 20. Negative 20 plus 4 is negative 16. So that one works. Very last one for this video. If you're feeling pretty confident, you might like to pause it and try it before I do. If not, follow along with me. A number is divided by 11. A number we don't know. I'm going to call it x. How original. Here we go. X over 11. Since it says divided by 11, we don't want to do this because we don't like to use this symbol when we are using algebra. Okay, x over 11, and then 6 is added. Okay, the result, so what this whole thing is equal to is 13. Okay, let's take away that 6. That leaves us with x over 11. Okay, 13 minus 6. 7. Oops, I've just made a mistake because I've just added that in when I shouldn't have. Because we just took away that 6, so it's not there anymore. Okay, so x over 11 is equal to 7. So now let's times both sides by 11. Like so. This cancels out from this side, leaving us with just x, and 7 by 11 is 77. There we go. So we can check it. 77 divided by 11 is 7, and 7 plus 6 is 13. So I know that I've got it right. That's where I'll finish. What I might do in class is show you why I wouldn't times by 11 first, just so that you can see why that's not the right move. But for now, I'm going to stop there so that you can get some practice on this.